So hello everyone, let us continue with where we have left in the last session. We have discussed about the representation of linear array in memory. Let us continue further. So there is a question in case of one-dimensional array that how do we calculate the address of any particular element inside the one-dimensional array. The starting address of the array is your 500 given in the question. Lower bound is also given and every element is occupying 2 bytes of memory, where the array is your linear array which is of size 40. So we need to calculate the address of the 4th, 8th, 26th and 32nd element. So based on the formula which is given here, so this is the memory address of a linear array's kth element. This is the base address of linear array. This is the width that is represented by 2 bytes of memory here, width of every element inside that array. And this is the position whose address I want to calculate. This is the lower bound value which is given here as 1. So as per this question, we have to calculate the address of 4th, 8th, 22nd and 32nd element. So as per the formula, if we put the values here, 500 is the base address, 2 is the width, 4 is the position k and 1 is the lower bound value in our case. So it will come out to 506. Similar is the case with the other memory addresses for other elements. Suppose for 8th element it will be 8 here, rest will remain the same, it will give you to 14, 514. Then we have 26 replaced here, it will give me 550. 32 replaced here, it will give me 562. So this is how we can calculate based on the given formula for one-dimensional array. Now another type of question that can be asked is in this way. Suppose this X is a linear array and Y is also a linear array. We need to identify first the length of the array and then we have to calculate the address for these particular elements inside the X array. So what is the meaning of this particular representation of the array? This is basically 4 as referred as the lower bound and 50 as referred as the upper bound of the array. And this in case of Y is also, this one is your lower bound and this one is your upper bound. So in case of representation, this is another way of representing your 1D array with upper and lower bound. And here -4 is given as the lower bound value. So if it's like a hypothetical situation, generally it doesn't occur because in case of normal C programming, we don't go into negative direction in case of indexes. So it should not be there, but in case it is provided, so how do we calculate that or use it? And every element of array is also occupying 4 bytes of memory. So in order to solve this first part, that is A part, this is the formula. Length of array is basically upper bound minus lower bound plus 1. So we can put the values and we can calculate the length of the array. And this is the formula as per the previous question also for calculating the base address, or you can say the memory address of any particular element at a given position inside the 1D array. So let us start with the A part first. This is how we can calculate. 50 is the upper bound, 4 is the lower bound, add 1 to it, it will give me the length of that particular X array. Now similar is the case with the Y array. This is the upper bound minus 4 which is the lower bound plus 1, it will give me 50. So these much number of elements can be stored inside X and Y respectively. Now coming to this part B. So as per the formula given to us, we can put the values for X12. This is 400 base address, 4 is the memory occupied by every element which is in bytes. Then this is the position 12, this is the lower bound which is 4 in case of array X. So it will give me 432. Similar is the case with X33, 42 and 55. You see the 55 case separately. So this is the case with 4 different positions inside your 1D array. If we talk about this X55, so it is saying that out of range exceeds the upper bound 50. So we are saying that upper bound of an array will give me the location up to which the elements can be addressed. So next is about your operations on the linear array. One of the operation is your traversal. So how we traverse that? Traversal basically means that accessing and processing the elements of the data structure, in this case array, exactly once. So suppose this is the representation of the linear array. This is the element position separated by these spaces. So this is up to the end of the array. So this is how we can traverse the element one by one. In order to traverse the element one by one, we need to access each and every element based on the index position given inside the array. And this is how the algorithm will look like. We need a looping statement as per the programming language support. So we have to repeat up to the, from lower bound up to the upper bound, starting from this kth position, or you can say the lower bound. So apply process to LAK. LAK is basically the linear array with the position value as k. So initially it will be lower bound, it will go up to upper bound value. So it can be suppose 0 and it is going up to the value 5. So 0 to 5 means upper bound is the maximum limit. So 0 to 5 will give me suppose 6 elements which can be stored inside the array. We can apply the process on those elements. Process means like traversing them and performing some sort of operations on them. So that can be your process operation. Now next is another type of operations that we can perform on the linear array, insertion and deletion. So if we talk about insertion, it is basically adding an element to the linear array. If we talk about deletion, removing the element. So in case of insertion, it can be done at the beginning position, or it can be done at a given position or middle position, or it can be also done at end position. So we can insert at these respective positions inside the array. Similar is the case with the deletion. It can also be done at beginning, at the end, or at a given position or a middle position. Let us start with the insertion first. This is how the array is given to me, which is having suppose 5 elements, starting with the lower bound as 1. So this is my lower bound which is given as 1. In case of C programming, if we are talking about arrays, one-dimensional arrays, 2D arrays, the indexing always starts with 0. So generally, in case of programs, will start with the indexing 0, but here for understanding only, we have used the lower bound as 1. Suppose these are the elements. I want to insert the element at the end of this array. So this value freedom has to be inserted at the end of the array. So end of the array is basically this one in which there is no element added after this 5th position. So it will be end of array. This is the complete size of the array, and this much is the elements which are being stored inside the array. So I have to insert the element, so it will be inserted at this position, considering after 5th there is no further element. So after performing insertion, this will be the output. And in order to perform as per the algorithm, we need to go to that index position and we have to store the value inside that particular element. So next is the case insertion at the 3rd position, or you can say the 3rd element of the array. So 3rd element is this one, Johnson. So we have to move this Johnson somewhere in order to add this freedom to that 3rd position or as the 3rd element. So in order to perform the insertion in this case, what we have to do is we have to shift every element down one position from this particular location, or up to this particular position, or the 3rd element position. We have to shift every element one position down. So if we perform this operation, first white will be moved down, then Smith will be moved down, then Johnson will be moved down, and we get this 3rd position empty. Once this 3rd position is empty, what I can do is I can insert this freedom value inside it like this. So this is how the insertion will take place. As you can see, insertion at a given position will make this operation to be performed by shifting every element from that position one position downward. And in case there are no spaces inside the array already, so it will lead to the loss of data. So that means insertion is not possible without the loss of the data in case the array is full. So that means if we are elements up to this 8th position, so in order to shift this freedom inside the 3rd position, so I have to shift every element one position down. So it might be possible that this 8th element will be deleted out of that array. Similar is the case with the deletion. If we have this data for performing deletion inside the array, so if I want to delete at the end of the array, directly have to go to that position and remove that element from inside the array and decrease the number of elements which are stored inside the array by -1. So if I delete it, so 7th position will be empty, and this is how the deletion will go at the end of the array. In case I want to delete a particular element or at a given place, suppose this tray has to be removed from the array. So this is the second element which has to be removed. So in order to delete this element, first we can delete the element or remove that particular element, and then we can populate or move every element beyond this up to the end of the array, one position upward. So in case of insertion, we go one position downward from that location up to the end of the array, and in this case we have to go one position upward up till the end of the array in order to delete the given element. So once that element is deleted and every element is shifted one position upward up till this last location, that is 7, so this will be the outcome. Okay, so this is how the deletion at a given position can take place inside the array. Then we have, if the array is empty, we cannot perform deletion, so it can give you an error message like this element is not deleted, or you cannot delete element because it is not containing any data. Then we can have the algorithms for the descriptive operations of the array. Suppose to start we will discuss with the kth positions, because that is more over complicated, we can say, better to understand that a given position. So we start with this. So in this case we have this as the algorithm name, insert. It is asking, or it is taking input as the linear array represented by LA. This is the size or total number of elements inside the array. This is basically a element which can be referred as this POS also. It is basically the position where I want to insert the element, and this is the element value, that is item here, which I have to store inside a particular position. So linear array represented by LA, n is the number of elements, and POS or k is a positive integer such that the position is always less than equal to the number of elements inside the array. So in order to insert the element item into the kth position, this is the algorithm. So step 1 is we have to initialize the value of a counter variable, like this j is referred as a local variable, counter variable, which will be counting the elements inside the array. So it is initialized to n, so it is initially indicating that there are n elements, so we'll start with this n and repeat the steps 3 and 4 while this j is greater than equal to position. As we have discussed the scenario of insertion at a given position or the kth position, so in that case we have to shift elements downward. From where? From this particular or up to this particular position POS. Else we can print that it is out of range. So if j is beyond this, so we can say that it is out of range. So move the jth element downward. So j is initially n, that means it is at the upper bound of the array. So, or you can say that last element where the element is inserted, as n is representing number of elements present inside the array, it is not the upper bound. Upper bound is a different, or it can be a different one, although n can be equal to upper bound also. So we can perform this operation, linear array of j plus 1, that is the element which is one step, or the location which is one step further. It will be storing the value of element which is above it, that is LAJ. So we keep on performing this operation and every time incrementing the value of j by 1 or decrementing the value of j by 1. So it is initially n, then it will be n minus 1, then it will be n minus 2, and it will go up to this particular POS position in order to shift every element one position downward. So up to this position we shift every element downward, and once this position is reached, shift that element, and after that we'll stop the step 3 and 4. Then once that position is empty, as we have shifted one position down from that particular position to the n position, So we can insert that item which I want to insert inside this particular position of my linear array. This is how the insertion at that particular place will go. And finally we have to increment total number of elements which are increased to 1. So that is how n is representing n equal to n plus 1. So this is all about your insertion algorithm. After that we can stop or exit. So simple as that. So let us continue further. We have to perform the deletion at the kth position because these are more important algorithms as compared to insertion at beginning or end. So this is again a name of the algorithm, delete. It is holding linear array as input. N is number of elements, POS is the position where deletion should happen, and this item is the value which will be collected as part of that deleted element. Here it is not the value which I want to insert, here it is the variable which will be storing the value of the deleted element so that I can process it or I can print that particular thing. So this kth is basically the POS position which is part of this particular delete function. So let us continue with this algorithm. So initially as part of the deletion, from this particular position I can extract the element and its value will be stored inside item. So that means item is now stored inside. The element which has to be deleted is stored inside this item. After this we have to repeat for j is equal to position to n minus 1. Means for position starting with this particular value up to the n minus 1 location we have to shift every element upward. Okay, one position upward, every element has to move in case of deletion as per the algorithm. So this positions will be storing the value of the element which is one position down of it, that is position plus 1. So this is how we can keep on performing the operation. After every operation, every element has been shifted one position upward, starting from this position to n minus 1. We decrement the values of element or number of elements inside the array by minus 1. And after this we can exit our program. And internally in case of writing your program, you can print this value of element deleted, that is this item. This is how the deletion algorithm can work.